Alright, in this video I'm going to use the limit definition of the derivative to find the derivative, to have an appreciation of how the limit definition of the derivative comes about. You might want to watch our first video on the derivative. Alright, so in this video I'm going to find df dx using the limit definition. Alternatively, this question can be posed as follows: find df dx from first principles. Okay, so we have like 6 functions here that we're going to find the derivative of using the limit definition. Before we start off, I'm just going to excuse me, state the limit of the definition here. So df dx is the limit of f of x plus h minus f of x divided by h. So that is the limit definition, or the formula we use to find the derivative from first principles. Before we do any calculation here, we're just going to note that if you do direct substitution here, so direct substitution means plugging h is 0, you're going to have f of x plus 0 minus f of x divided by 0. So this is f of x minus f of x over 0. So this is giving us 0 over 0, which we called the indeterminate form when we studied limits. Now we said whenever you get the indeterminate form, what it implies is that there is a common factor in the numerator and the denominator. So what you need to do is to simplify and factor out the common factor. Okay, simplify and factorize the common factor, and then after that we cancel out the common factor, and then once we've cancelled out the common factor, then we are going to substitute directly. In this case, we're going to substitute h equals to 0 because we're doing the limit as h goes to 0. So that's a bit of background, but otherwise it's going to be helpful for you to have a look at our videos on limits. So for example number A, we have f of x equal to 4x minus 7. Just before we work this out, okay, so remember f of x is y. Y equals 4x minus 7 represents a straight line, and it's a straight line with gradient 4. Okay, i.e. Straight line with gradient 4. Now remember, we say the derivative is the gradient, so that means here we just expect that our answer is going to be equal to 4. Okay, now so in this formula here we have got f of x, and we've got f of x plus h. So that means here we need, from this, we need to find f of x plus h. How do you find f of x plus h? Well, from f of x, every x is replaced by x plus h. So here we're going to have 4 into, it was 4x, is now going to be 4x plus h. Okay, then we're going to remove brackets here. There's going to be 4x plus 4h minus 7. Okay, then we are going to substitute. So df dx, which is the limit as h goes to 0, f of x plus h minus f of x. Okay, then we are going to substitute 4x plus 4h minus 7. Is advisable to write these in brackets. Okay, now if we did direct substitution here, like I mentioned earlier, if we plugged in h is 0 here and here, the numerator will be 0 and the denominator will be 0. So that tells us what we need to do is to first simplify, then factor out and cancel the common factor before we plug in h equal to 0. So if we do that, so this is going to be 4x plus 4h minus 7. Remove the brackets this side, it's going to be minus 4x plus 7. Okay, then in the numerator some terms are going to simplify. 4x minus 4x cancels out, minus 7 plus 7 cancels out. Then in the next line we are going to have 4h over h. Now we see we have got that common factor of h like we were saying, so that one cancels out, and so we now have, so this is limit as h goes to 0 of 4. Okay, which as you can see does not involve h. So if we substitute h equals to 0, we get 4 anyway, which is what we expected, because we said the gradient of this line is 4. Then in example number 2b, we have got f of x equals to k, where k is a constant. So let's see how this is going to work out. So f of x is equal to k. We need to find f of x plus h. Well, in this one, there is no x, well, or rather the x is there, and it's hidden, as if you like, because that's the same as kx to the power 0, where of course x to the power 0 is just 1. So if we plug in x plus h for every x, this still remains k. So that means our derivative, which is f of x plus h minus f of x, so this time this is going to be k minus k all over h. K minus k is 0, so this is 0 over h. 0 over h is 0. So, and if we substitute h is 0, that is going to give us 0. That shouldn't really surprise us, because here we're dealing with y equals to k, and y equals to k is just going to be a horizontal straight line at y equals to k, and as you can see the gradient of this line is 0, so that's why we are getting derivative is 0 there. Okay, then in C we have got f of x equal to x squared. So this time we've got a parabola. So this graph goes something like this. The gradient of this changes at every point. So this time is not a straight line. So for a straight line, gradient is the same right through the domain of the straight line. But for that parabola, this one for instance had gradient 4, the y-intercept was -7, so that line was looking something like this. But m is 4 at every point on this straight line. M is 0 here at every point. But here, as you go along this graph, the gradient changes. In particular, on the right hand side of the origin, gradient is positive. On the negative side, gradient is negative. For instance, that's positive gradient, that's negative gradient there. All right, so in order for us to use the limit definition again, we need to find f of x plus h. So this time, if we plug x plus h in the place of x, we want to get that. If we expand that using the binomial expansion, we're going to get 3 terms: x squared plus 2xh plus h squared. Then when we plug this into the formula for the derivative, so this thing is going to be the limit as h goes to 0 of x squared plus 2xh plus h squared, and then f of x is just x squared. Okay, then this is all divided by h. Okay, if we remove brackets here, all that's going to happen really is the x squared is going to cancel out, so that and that cancels out. So this is going to be the limit as h goes to 0 of 2xh plus h squared. Remember, the aim of the simplifying is to identify the common factor. Typically, the common factor for these calculations is always going to be h. Okay, so in the numerator, I can see that there is a factor of h, which we take out of the brackets, and so now this cancels out, and so this expression going to be limit as h goes to 0 of 2x plus h. At this point, after cancelling out the common factor, we plug in h is 0, so this is going to be 2x plus 0, means the derivative of x squared is 2x, right? Okay, in D we have got f of x equal 1 over x. Again, this one, if we recall what the function or the graph of this function looks like, it's going to have 2 branches, and the notable thing is that the gradient is always negative. So you can see this side is going it's down sloping, and this side is always down sloping. maybe before we go to this one, 2x, you can see that 2x, this side 2x is always positive, like we're saying, gradient is always positive, and this side 2x is going to be negative, because if you plug in any negative value of x here, you're going to get something negative. So for this one, we expect that the gradient must always be negative. Okay, so let's see. F of x plus h is going to be 1 over x plus h. Then df dx, which is the limit as h goes to 0, f of x plus h minus f of x. So this one is going to be equal to 1 over x plus h minus 1 over x, all divided by h. Okay, and so we need to extract the common factor, because if you just plug in h is 0 here, this thing is going to give us 0 over 0. When we have fractions, we always seek to write them as a single fraction. So this fraction here, we're going to want to write it as a single fraction. The LCM is going to be x into x plus h. Okay, then we ask how many times does this go into this, and the answer is it goes x times. And then how many times does this go into this? It goes x plus h times. The brackets are important. And then this h here is going to tuck in there. If we simplify now, let's maybe remove the brackets in the numerator. We have x minus h. Okay, and then of course x minus x cancels out, so the numerator is now going to be negative h, and then h cancels out, so this is now going to be the limit as h goes to 0 of minus 1 over x plus h. After cancelling out h, we can plug in h equals to 0, minus 1 over x plus 0. This thing is going to be minus 1 over x squared. Now, since x squared is always positive, means this whole term here is always negative, and that is in agreement to what was suggested when we looked at the graph of 1 over x, that the gradient is always negative. Okay, 2 more examples, and then perhaps we're going to give you something that you can try. In example number E, we have f of x equals square root x. Square root x, again, if I can just make a sketch of this, square root x is only going to make sense when x is positive, so it's only going to be located this side, and it's going to look something like this. Okay, it's basically just this parabola rotated through 90 degrees, like this. Okay, but then as it is, it's not a function, so to make it a function, you have got to lose one of the branches. So we lose this branch, and then we end up with just that one there. Okay, so that is the graph of square root x, and you can see here that the derivative is always going to be positive here, because this is always going up. Okay, so let's see what the limit definition is going to give us. So f of x plus h is going to be the square root of x plus h. Okay, not this. So since the x is inside the square root here, then x plus h must also be inside the square root. So df dx, or f prime, indeed, depending on which one we prefer, x plus h minus, notice that I am always starting with the formula, and this is advisable. So square root of x plus h minus square root of that over that. Now, so again here, if we just plug in h equals to 0, we're going to get 0 over 0. Now, because we have got square roots here, if you check again our video on limits, we will have mentioned that whenever you have got the indeterminate form in expressions involving square roots, what we want to do is to rationalize. That means do an algebraic manipulation of the expression, which is going to get rid of the square roots. So in this case, we do that by multiplying by a term similar to this one, but involving the opposite operation to negative. So that means this one is going to be positive. So we have got to multiply both the numerator and the denominator by that same term, so that the expression is not changed, because technically this is just 1. So just multiplying this thing by 1. And then in the numerator, because we have got a difference of 2 squares here, then this is going to be x plus h. Basically, you're just going to get this squared minus this squared. So that's what the difference of 2 squares does. In the denominator, we're just going to end up with h times that. And then if we simplify in the numerator, then you can see that the common factor of h has now been unveiled, as it were, because it was concealed because of the square roots. So the square roots are gone, and we can see the factor. So we cancel out h, and so we are now going to have the limit as h goes to 0 of 1 over square root x plus h plus square root x. Okay, so once we have cancelled out the common factor of h, we plug in h equals to 0. So this is now going to be x plus 0 plus that. So this is going to be 1 over 2 times square root x. And since square root x is always positive, that means this thing is always positive, which is in agreement with what we expected from the graph here, because the graph is always uprising, so the gradient is always positive. All right, Just one more, then we'll give you two to have a go at. Now in f, we have got f of x equal x to the power n, where n is a real number. Actually, this is going to give us a result that covers E. It also covers D, and it also covers C, because all these functions are powers of x. So in C, we had x squared. Okay, we could have gone on to do x cubed and x to the power 4, etc. Then in D, we had 1 over x, which is simply x to the power minus 1. And then the next one was square root x, which is simply x to the power half. All these are powers of x. We could have many more. We could have x to the power 2/3. Okay, so instead of doing all of them, we'll just do this one here, where n is a general real number. Okay, and then that result is going to cover all these ones here. This is going to need us or you to review a bit of your binomial theorem. Okay, so because we've got a binomial here, what we're going to do is we're going to just work out the first 3 terms, and then that's going to be good enough. So according to the binomial theorem, the first term is going to be x to the power n. Then the next term is going to be n times x to the power n minus 1. So the x terms, the x powers, are going down and the h powers are going up. So here power of h was 0. It's now 1. Here power of x was n, is now n minus 1. So powers of x go down, powers of h go up. Then for the next one, we're going to have 1/2 n into n minus 1. This is now going to be x to the power n minus 2 h squared. And then there are going to be many other terms. All right, so that is f of x plus h. Okay, this time I'm just going to work out this term before plugging in. Okay, so I'm going to bring f of x here. Okay, then we're going to subtract. So f of x plus h minus f of x. Okay, if we do corresponding terms, this term minus this term will be 0. So this is just going to be these terms here. Okay, so n x to the power n minus 1 times h plus 1/2 n into n minus 1 x to the power n minus 2 times h squared. Now the thing to remember is that the powers of h here are going up. So h here, h squared, the next one will have h cubed, then h to the power 4, etc. So all these terms will have a common factor of h. So we can write this thing like this, n minus 1 x to the power n minus 2 times h now, etc. Okay, so our derivative df dx is going to be the limit as h goes to 0, f of x plus h minus f of x over h. Now the numerator is just this term here, so we're going to have limit as h goes to 0, h into n times x to the power n minus 1, 1/2 n into n minus 1, x to the power n minus 2, etc. Then the common factor of h we can cancel out, and then this thing is just the limit of n x to the power n minus 1 plus 1/2 n into n minus 1 x to the power n minus 2, etc. Now remember, all the terms here involve h. So when we substitute h equals to 0, this one does not involve h. This one has got h, we plug in 0, that disappears, and all the other terms are going to disappear. So what this thing is saying is that derivative of x to the power n is n times x to the power n minus 1. This is actually one of the, it's going to form one of the rules of differentiating when we go on to the next section. Okay, otherwise for now, let's give you 2 examples to try. Okay, so we did f, so g, if you want to have a go at f of x, equal 3 minus 5x, and h, have a go at f of x, equal 5x squared plus 1. Just have a go at those two, pause the video, try them, and then when you continue the video, you can compare with our answer. Alright, we hope that you have now had a go at this G and H. We're now going to scroll down to our answers. If you haven't, please do. You will benefit, get the maximum benefit from these if you have a go at the exercises. Right, so for G, we're given f of x is 3 minus 5x. So we are going to work out f of x plus h works out to 3 minus 5x minus 5h. Then if we plug into the limit definition, start with it like this, remove brackets, then you can see that 3 is going to cancel out, 5x is going to cancel out, so we're going to have minus 5h over h. And again, h cancels out, so we've got a limit of minus 5, and so the derivative is negative 5. This time again we've got a quadratic, 5x squared plus 1. So if we work out f of x plus h, it works out to 5x squared plus 10xh plus 5h squared plus 1. If I plug this into the limit definition and simplify, numerator works out to 10xh plus 5h squared with a common factor of h, which we factorize. Then we can cancel out h, so we've got 10x plus 5h, and then we can now plug in h equals to 0, so the derivative is 10x. Thank you for watching. Hopefully you find these useful. Please subscribe so that you can get notified whenever we post new stuff. Thank you.